Everyone, the tech teacher here. Today we are going to go through an interesting yet tricky LeetCode problem. It's called longest zigzag path in a binary tree. Before we start, if you like our content, drop a like to the video, subscribe to the channel, share the video and enable notifications so that you receive our updates as soon as possible. Let's start by reading the problem statement. So basically we are given a root of a binary tree. A zigzag path for a binary tree is defined as follows. Choose any node in the binary tree and the direction, right or left. If the current direction is right, move to the right child of the current node. Otherwise, move to the left child. Change the direction from right to left or from left to right. Repeat the second and third steps until you can't move in the tree. Zigzag length is defined as the number of nodes visited minus 1. A single node has a length of 0. Return the longest zigzag path contained in that tree. Right. So for this example, this is the zigzag path 1 1 1 1. It's 4 nodes, so the length is 3. The reason why this problem is tricky is that the result can be any zigzag path, not necessarily starting from the root node, which this is what makes it tricky. In the second example here, the longest zigzag path is this way, 5 nodes, so the output is 4. And for sure, if we have a single node, then the output is 0. We have a minimum of 1 node, and we don't care about the node value in this problem. So let's start thinking about this problem. So normally in tree-based problems, it's usually the solution is usually a recursion. We will solve this problem in 2 ways. Both will get accepted. The first way is easy and simple, but it's not clean. So it has a better time complexity, memory usage, but it's not the best cleaner code for an interview, for instance. Let's start. So we will solve it basically using a normal DFS like this. So we'll start by, let's first start by defining our DFS function. So it will be private void DFS, and it will take a node, and it will take a boolean indicating whether this node is on the left side or not, and it will take the steps so far to reach this node, right? So if the root is null, then I should return, right? Otherwise, if this node is on the left side, then I should go on the right side for the next step, which is DFS root.right, and then is left will be false, which is not is left, and steps will be the current steps plus 1, right? Otherwise, I will do the opposite, which will be I will go to the left, is left will be true, and steps will be steps plus 1. So what does this do? So this basically goes through the paths from the root like this. Let's start by calling the methods from the root. DFS root.left, and it's on the left, so it's true, and value 1 because I only moved 1 step. Then DFS root.right false, and 1 because I moved only one step. Then let's take care of the return later. So what does this do? So it starts from the root node, and then it alternates zigzag path on both sides, right? So the problem with this solution is that it only assumes that we start from the root node. However, we should try starting from every other node. And the way to do this is to call here another call, right? So for instance, here I'm calling root.write, which is on the right side. However, this means that I never visit the left child of this node. So I should visit the left node as well. It will be on the left, true. But here, for the steps, it will be only 1. Because assuming that I am here the new root for the tree, so I will be moving only one step to go to the left node, similar to this call, right? And the other way here. By this, I'm assuming for every node either to go through the normal zigzag path, or assume that's the root node of the zigzag of the new path and try this path as well. So the only remaining thing here is to maximize or get the maximum steps. But the problem here is that the recursive paths aren't connected in a way. There are 2 parallel paths computing at the same time. So this will cause us to add a public variable here. Let's call it maximum, right? Initially equal to 0. And then here, maximize this variable over the steps so far for the current node and the maximum. And then here we will return this max, right? Here is it. So we have, because for every node we have like 2 return variables. One is the cost from the normal zigzag, and the other is the cost assuming that maybe 3 as well, like the cost for normal zigzag and the cost if I'm the left or even if I'm going on the right side. Let's run this to make sure it's working. It's accepted. Let's submit. Woohoo! So it got accepted. But this is not the end of this video. Let's go back. So we will try to implement another solution that may be a little bit more complicated in its implementation, but it will be cleaner. And for a real interview, I would recommend proposing both solutions but implementing the second one, because it's more clean and more modular in a way. So let's clean our solution and start implementing the newer solution. So first we should realize that in order to have the return variable from 2 different methods, we should have a wrapper class. And then let's think about this DFS method. So I'll start first by creating this class. Let's make it private. Class, I call it item, you can call it, or maybe wrapper. And then it will have the left coast and it will have the right cost. But we can add another field as well, which is the maximum cost found from this node, right? Let's have the constructor public wrapper take int left, int right, and int max, and it will be, this is just a boilerplate, this dot left equal left, this dot right equal right, and this dot max equals max, right? So here we have created our class with its constructor. That's nice. Let's remove this method. So what should we do? So for every node, we need to calculate. We will have a helper method like this. Let's call it with the same name like this. Private. This method will return a wrapper, and it will take a node, right? So this method should return three things, which is the wrapper. The first field is the cost if I went on the left side of this node, and the second field is the cost, or the number of steps, if I went on the right side of this node, and the maximum will be the maximum steps in if this is the root node of the path. That means that if we have here this method called on the root like this, the result will be this method dot max, which is the maximum steps from a given node. Let's start with our base cases. So if root is equal to null, similar to the previous solution, we'll return a new wrapper. Left will be 0, right will be 0, and maximum will be 0. That's fair. Now let's start by calling our recursion. So for every one of them, for every node, we should try both passes, either left or right. So that makes us define wrapper left is equal to the recursive call on root.left, and we define wrapper right equal to the recursive call on root.right. That's fair. Then we should return a new item, a new wrapper like this with 3 fields, but we need to define to see how are we going to fill these fields. So we have left, and then right, and then max, like this. Cool. So what will be the cost in terms of for the left side? So for the left side, I think it will be easy. First, we will add 1, which is the current node, right? And then, assuming that the current node is the right side, we will need we need the zigzag form, so we will need 1 plus the left dot right in order to get right steps, in order to get the zigzag coast. Same goes for the right side, which is 1 my current node plus the right node dot left coast, right, in order to get this zigzag coast. Now back to the maximum. So the maximum is a little bit tricky. Let's define it in a variable here. So first we will need math.maximum between two fields, which are the left dot maximum in order for this to accumulate up, and the right dot maximum. But the problem is these are not enough, because the maximum may be the coast adding this one as well, which is the zigzag coast, like the left dot max, the left dot right, and the right dot left. I know this is a little bit tricky, but let's explain it somehow again. Let's write it up first. Yep. And then explain it, and then call it max here. Right? So the idea here is that we need the maximum for this node as if it's the root of the new path, right? So the coast is either the maximum coast from the left or right subtrees. At this case, this current node is not involved in this path, right? Or if this node is involved in this path, then it will be left dot right path, meaning the zigzag path, or it will be right dot left path, the zigzag path on other side, right? And this is the tricky part to replace the kind of global variable that we have. Let's run it. So we have a compilation error here. Yep, because they have the same name. Let's call it helper, and let's call this one helper as well. Run. So it got accepted as well. Submit. Oh, so it got accepted. You will notice that it's lower in memory and probably in time as well, because it allocates extra memory for these classes, for these objects. However, it's much cleaner than the previous solution, especially if you are applying for a large company that cares not only about the time complexity, but also about the code being clean and being testable, doesn't have a global state. I would also recommend that you discuss both solutions with the interviewer and confirm the desired approach first before choosing which one to start with in your implementation. I hope you liked this video. We will take more problems in the future about the same topic, the same idea. And at the end, if you like our content, share and like the video, subscribe to the channel, enable the notifications so that you receive the updates as soon as possible, and I will see you in the next video.